today we're going to do some real-world applications with vectors. And so typically these problems, I'm going to let you know, it's a boat, it's a plane, it's a swimmer. That's usually what they are. Okay, occasionally there's some other workforce ones. If you take physics, you've probably seen these problems or you will see them. And if you take physics in college, you'll see them. Okay, so the first thing I have, the pilot of a plane points his plane due south. So first thing, you need to make sure that you know your compass direction. These initial problems that I'm going to give you are going to be very simple. They would either be north, south, southwest, northeast, those types of things. And then the next ones that we move to will be slightly different, but I will try to make them as easy as possible too. So I have an airplane that points south. Okay, there's my airplane, and it is traveling at 120 meters per second, miles. I think it's supposed to be miles per second, sorry. Okay, now, there is a wind blowing on the plane. Yeah, meters per second. All right. It's an airplane, not a car. Goes fast. Okay, so there is a wind blowing west. Show me with your arms which way west is. This way, right? If I put this here, it doesn't work. Okay, because we have to do the head to tail method, right? So the wind is blowing west. So I can either put it up here like this, or I can put it down here. Okay? I chose to put it up here. Is my vector pointing west? Is it acting on the plane? Yes, it is acting on the plane, and it gets a 40. Okay. Can anyone tell me the degrees of this angle right now? Does anyone know? How did you get 90? Okay, because I have a perfectly vertical line, which is the south line, and a perfectly vertical line, which is the west line. So north, south, east, west, they intersect at a right angle always. So that is a right angle. Okay. Now, a resultant vector goes from an initial point to a terminal point. So I only have one initial point left. Where is it? Describe it to me. Where is it? It's the east of the line. Okay, right there. So my initial to my final terminal, this is the only case where initial, terminal, terminal. Okay? Now the angle of the resultant vector is always the angle where the two initials come together. So that is this angle up here. Okay? So question A wants to know, we're going to start with question B because it's easier. They want to know the speed of this resultant vector here. How might I do that? Pythagorean theorem. So I'm going to do 40 squared plus 120 squared and then square root it, which is the same as what that you've been doing the past couple days? The magnitude. It's the same as the magnitude. But if we don't remember that, we always remember Pythagorean theorem, right? So we're going to go ahead and use Pythagorean theorem and find the resultant speed, which is question B on your paper. An answer. Who's got an answer for me? Yep. 126.5. Do I have a second? Did somebody else second that? Okay. We're going to go with it. 126.5 meters per second. Okay. How might I, now, what type of triangle is this again? It is a right triangle. How might I find that resultant angle? This angle here, how might I do that? I could use the law of sines, but it's a right triangle, so there's something simpler. Just trig identities. I can use SOHCAHTOA. We're going to use the two given. We never use one that we found in case we made a mistake. So compared to the angle, 120 is opposite, and 40 is adjacent. So which trig identity uses opposite and adjacent? Tan. Am I going to use tan or inverse tan? Why inverse? I'm trying to find an angle. So I'm going to do inverse tan of 120 divided by 40, which will give me approximately how many degrees? How many? 71.5 degrees. I would also accept 72 degrees. That is only half the answer. What direction is that arrow pointing? Southwest. Done. And the second B, that should really be a C on problem number 1, we are not doing. You can go ahead and cross that out. You don't need to know that for our purposes. So this is A. This was B. We did B first. B was the 126.5 and A was 71.5 degrees southwest. Question? No, the speed is this 126. Because question A said, roughly in what direction is the resultant vector? So the angle is the direction. And then this is the speed. Yes? If we do it the other way, no. Let me show you why. That's a good question. I'm glad that you brought that up. So if I had put it here, right? Because it has to be head to tail, right? This is my initial. So I have to go from an initial. This is the only initial left. So when I go here, this line is still pointing which way? Southwest. Okay, so it does not matter. And the reason why this is called the parallelogram method, and you guys should have learned that in geometry. I don't know if it's still in the curriculum. If you notice, let me get out my highlighter. No matter which way I went, it makes that parallelogram. Okay? Just remember that the resultant has to start at the original, at an original initial, and have a terminal at a final terminal. Okay, so do you guys see how I could have drawn this one or this one and still gotten all the same answer? Because I would have looked for this angle up here, and this line is still pointing southwest, yes? Okay, let's move on to the next one. So, I am going to go over to A and B. I will tell you when they do assessment, they don't ask these types. You already know the skills for these, okay? So there is a swimmer, and if they go to a pool, they can swim 5 meters per second, okay? If they're in a pool, they can swim 5 meters per second. What doesn't exist in a pool that exists in the ocean? A current, okay? All right, so if I'm in a pool, the current's not affecting me, okay? So, this swimmer is swimming east, and the current is pushing east. So is the current going to help or hinder the swimmer? Help. So it's going to be a combined vector. So it's going to be vector u plus vector v. All right, so what is the speed of vector, the original speed? 5, and the speed of the current is 3, making the speed 8 meters per second. That is for letter A. Now, they won't ask that. They'll do u plus v. Okay? Now, question B says that the swimmer is swimming east, right? And the current is going west. So is that helping or hindering? Hindering. So that's going to be subtraction. And also because they're going in opposite directions, right? 5 minus 3, which gives me 2 meters per second. Now, if you did 3 minus 5, that's fine. You would have gotten negative 2, but speed is never negative. So you would have just said the speed was 2. Okay? speed is always that absolute value. Okay, good. All right, now let's look more at problems like you would be asked. We're going to do 2C. And it says that the swimmer is heading which way? Does the swimmer want to head? North. Okay, so my swimmer is heading north. This is called what? Initial, and this is a terminal. And how fast is the swimmer going? 5. Okay? My next vector either has to start at a terminal or end at an initial. Okay? So the current is pushing which way? East. So I can either put it here, yes, because that's facing east and it puts a terminal with an initial, or you could have put it up here. Okay? And again, because it would have made a parallelogram. Yes? Yes, ma'am? I could have if I put it up here. That's what I just finished this. Because that would be a terminal with a, that would be an initial with an initial. You're not allowed to. So the head to tail. Okay? The head of one has to touch the tail of the other. Okay? Now, the resultant vector is different. The resultant must take an initial and a terminal and connect them. Okay? So my resultant vector is going to take this initial location and this terminal, and it's going to connect them. That's the resultant vector is the only one where an initial touches an initial and a terminal touches a terminal, because it's a change of path. Okay? So my path of the current was here, and now it's here. So that is going to be the angle that I'm looking for, and I need to find the speed. So the length of this line will be my speed, my magnitude, and this angle will be my direction. So please find those two pieces of information now. And again, it's pure north, pure east, which makes it what type of triangle? It is not 4. Right triangle, it is not 4. 3, 4, 5 only works if the hypotenuse is 5. The hypotenuse is missing. All right, what do you guys want to start with? The angle or the missing side? Missing side, which is the speed, which I believe is question B, not A, yes? Oh, actually, C has them combined, sorry. Okay, so what is the length of the missing side? 5.8, great. And the angle? It is 59? I didn't mess up? Did I mess up? Did I say the wrong angle? 59? Oh, we didn't ask for the directional angle. We just went a step above. Okay, 59 degrees. 59 degrees which way? Northeast. It didn't ask for it in this question. Sorry, it just asked for the speed. Okay, so I'm trying to find this angle. So opposite adjacent. So tan inverse 5/3. Sorry, and this question didn't ask for it. That was an extra step. My fault. Why do I have to do inverse? Somebody tell me. Because you're finding an angle. You have the ratio, you're finding the angle. Because SOHCAHTOA is the ratio of sides, and it is in proportion. The ratio of sides is based on the angle measure, so if you want to go backwards or do an inverse, it gives you the angle. Cool? Another question? Yep. Because it'll ask you either direction or speed. Direction is the angle, speed is the length of the line, the magnitude. Good? All right. So jot that down if you're having a hard time remembering that. Okay, I want everyone to try number 3 on their own, bless you. 3 on your own. Let's see how you did with this one. A plane is flying due north at 80 meters per second. There is a wind pushing towards the east. Okay, so pushing towards the east, I put it there. Again, you could have put it up here, because then it would have made my parallelogram, yes? Okay, the resultant vector must connect an initial to a terminal. So here we go, like this. The angle is where the initials come together, so right here is the angle I would be looking for, and this is the side that I'm trying to find using 30 and 80. Using Pythagorean theorem, the length of this line, or the magnitude, would be, what did you get? 85.4. Okay, then I'm going to use tan -1 of 80 over 30, which gives me how many degrees for the resultant vector? Direct, what is, sorry, 60 what? 69.4 degrees in which direction? Northeast. Again, please remember that the first two have to be head to tail. The resultant vector connects that initial. It's like, remember we did when we were doing Pythagorean theorem, we had the hikers went one way and this hiker went another, and if they could have cut through the forest, the resultant is like if you're cutting through the forest. Now, if you put it here, okay, the wind pushing this way, this is an initial to a terminal would have been there. Okay? It makes a parallelogram, so it works either way. Good? Question? It's not going to tell you which one to use for speed. It's going to ask you to find the speed. So you have to do both. You have to find the direction and the speed. This is the speed. This is the direction. Yes. 87. Okay, we'll just have to double check and see what you typed in your calculator and make sure you didn't hit like a 31 instead of a 30. Okay, we'll double check. Yes? Okay, moving on. All right, so new paper that I put out on your desk. I have 100 Newton force pulling on an object, and I have a 50 Newton force pulling on an object, and they meet at a right angle. I need you to find the magnitude of that lovely dotted line. This is one case where the two initials come together because they're pulling on the same object. Kind of think of it as tug of war. So I have an object of some sort, and they're each pulling on it. I have 50 newtons, and sorry, 50, not 50 degrees. 50 newtons and 100 newtons of force. I also need to know the angle that each one of them is pulling at. So please find the resultant vector and the angle that each of them are pulling at. And in this, oh, sorry, this is still, you can use Pythagorean theorem because it is a right triangle.